All right. So I want to talk about this passwords and crypto stuff. And the first one is just a very common tech support issue, which is to get past a Windows password. If you have used full disk encryption, BitLocker, then this will not work. But if you haven't, then you can totally get into any Windows machine. So you'll have to have a local virtual machine for this. You cannot do it in the cloud. And you have to boot from an ISO file. This is why people have to physically lock up their servers. Because if you can boot from a USB stick or a CD or a floppy, then you can read anything off the hard drive. And it's sort of like stealing the physical hard drive and mounting it in another machine. So you boot from the installing disk is one simple way to do this. And then once you've booted from the CD, which can be a bit of a chore, you then get the Windows boot up screen, and you can now choose troubleshoot and a command prompt. So this is a Microsoft feature that makes it possible to fix your machine. You get a command prompt. And now you can do a very old trick that's been around for 20 years or more, back to Windows NT. You move utilman to some other file, and you put cmd on top of utilman in the C Windows System 32 folder. And the point of this is, now when you boot the machine normally, you can press the Command U key or the U key during boot up, and that will launch the on-screen keyboard, which is utilman, and that is now a command prompt. So during the boot up, you get a system command prompt which you can use to change passwords. So this is a simple way to hack past a password and get into a machine. So that's a standard trick. And then we should talk about Hashcat. If in the days of MS-DOS, passwords were actually stored in plain text in a file on the system, but now everybody hashes them so that if you get the ability to execute commands on the system and you can steal a file, you can't just read the passwords out of the file. And so if you use Linux and make a new user, then you can view the password hash. It's just sitting right there in the etch shadow file. So you see this is the line that's created in the shadow file when you have a user, and Linux uses a very secure password hashing system. This is the type 6, so you have the name of the user, a colon, then you have a dollars and a number, and this number tells you which version of the password hashing system is being used. And this is the most modern, most secure version, password hashes type 6. And the way they work is they add random letters to every password before hashing it, which is this part here called the salt, which is 16 random letters. And then they run it through SHA-512 5,000 times. And that's what all the rest of this stuff is. Up to the end, up to the colon here, that is all a SHA-512 hash. So that's the salt, and the rest is the hash. So these things are intended to make it very hard to steal passwords. The reason it does 5,000 rounds is to slow down the calculation so that the only way an attacker can crack a hash is to have a list of passwords and hash them all until it matches. And because you use a salt, even if two users used exactly the same password, it would add a different random salt to each one, so there'd be no similarity in the hashes. So you can't make a master dictionary of password hashes, which you can do on Windows. So the only way to crack a Linux password hash is to feed in a dictionary of guesses and calculate them all. So the way to make it secure is to slow down the attacker by making the calculation very burdensome. And the default calculation here is designed to take about 50 milliseconds to calculate a hash, so that when a user logs in, it's an imperceptible delay. But when a attacker is trying to calculate thousands and millions of password hashes, it really slows them down. And you can see the settings here in your Linux settings. It'll show you here it's using SHA-512 and 5,000 rounds of encryption. So you can, if you want to crack passwords, the best tool that is very popular now is Hashcat. So you can download a word list. This gives you a word list of 128,000 words, which is pretty small as password cracking lists go. But we don't want to bother using a big one just so you don't have to wait very long. And once you've got it, you can then crash the hack the hash with Hashcat. Now, Hashcat is intended to run on a machine with specialized hardware for this purpose. You get graphics cards of the right type, and then it uses the GPU, which is much faster than CPU. But if you use -- force, it will run even on a headless cloud server with no graphics card at all. It just runs more slowly. And so then you can choose what type of hash. This has dozens of hash types, and turns out that the Unix type 6 password hashes are M1800. And use your dictionary attack. You put the output here, you remove the ones that match, and you get a dictionary from here. So this is a very useful tool. And if you run it on your own machine with graphics cards, it'll run much faster. But anyway, Hashcat will just try every password and crack in, so you can quickly find the password for a weak password on a Linux system. And then you can start cracking more hashes. I've got a list of more passwords to hash here. I've got a password here that begins with the word P. Here's one that begins with S. Here's some Windows hashes from a real Windows 2016 server. Windows used an old system called LM hashes, which is here, and it no longer uses that system, but it fills this with a static value that contains no information just to keep the format the same. The modern Windows hashes are here at the end. That's the only part that matters. That's the NT hash, which is designed in 1993 and never updated, so it consists of one round of MD4. Anyway, you can crack those things, and with Hashcat also, so you can practice cracking some Windows hashes, and that's a common skill. You'll need that in a lot of pen tests. And then there's a few blockchain projects. Blockchains were real fashionable in 2017 when the price was high. Now the prices of Bitcoin is up around $9,000 or $10,000 again. So people might care. So you might want to learn how to use blockchains. It's certainly not an ordinary skill you use all the time like Wireshark. But if you're interested, you can play with a simple demonstration blockchain here to see how it works. And the point of a blockchain is you have blocks of data. And so if I put data here, like Sam has 10 coins, this is how Bitcoins work. You have these blocks contain data about who has money. So now it turns red, these blocks have not been mined. When you mine a block, it changes this random nonce until it gets a hash that starts with a certain number of zeros. Then that block is mined. Now you can put data here like Sam gives Joe 5 coins. And then when this one gets mined, that's fine. All right, and now the point is, the reason why this is a blockchain is because the hash of this block is included in the next block. And the hash of this block is included in the next block. So if here I say Sally has 3 coins, and I mine this one, yes, okay. Now, if somebody tries to change something, like Sam tries to have 11 coins, it breaks all the blocks. They all turn red, none of them match. So the point is, if you verify the latest block, and this matches, that verifies the whole chain. So the point of a blockchain is you can have a database that many people can add data to, but nobody can ever remove data or change any data. See, let me see if I can figure out who should be muted here. Somewhere is the list. All right, so I'll find out where that background noise is coming from. Anyway, so that's what blockchains do. And you can play with them here and find some flags, and you can set up a real blockchain. IBM is a huge investor in this. They've made a whole series of blockchain-based products. Many people believe that this is going to become a fundamental feature. So you can design Iroha blockchains here, which is designed for mobile devices. You can make your own blockchain on your cloud server. You install this thing, and then you can make a blockchain and see it go, where you do some transfer of assets from one account to another, and this is like a little financial blockchain. And then you can do a real hack. I'm not going to demonstrate it live, but this is, Ethereum has a thing called Remix, which simulates the Ethereum blockchain in your browser in JavaScript, so you can set up scripts. And this is a real attack that where someone stole $1 million. a few years ago. They made this thing called POWH coin, and they made a mistake in the code, so someone stole all the money. And so you can put the entire code is about 230 lines of this language called Solidity, which is used to write Ethereum contracts. And you can install it in your simulated Ethereum contract and deploy it. And then you can have it will create for you a simulated Ethereum blockchain with 10 users that have 100 Ether each, which is the Ethereum money. And you can then have a couple of them invest in this contract, and you can perform an attack. And the nature of the attack is that you are able to trick it into subtracting 1 Ether from an account that has a balance of 0. And it rolls under and turns into a huge positive balance. And that technique was used to steal all the money, almost $1 million from this a while ago. So you can simulate that account. You have these 10 simulated accounts, and you get to see how that attack works. It's very simple language, and it's very easy to make simple mistakes in your Ethereum blockchain. So there's a few crypto projects to get you started. I'm going to save this and